our colleague from the US who was supposed to give a webinar next week cannot do it, unfortunately. So she was supposed to give webinar 6, but due to some objective reasons, she will not be able to do that next week. The topic next week should be data sharing in public information sources. We will include this topic into the next training, which will be dedicated to watershed condition assessment. This is a training program that we will have at the end of the year. Just a minute, let me scroll the page down. I'm very sorry, I'm struggling with the technology. Just a minute of your patience. For whatever reason, it doesn't want to change the slides, so I will do it this way. So our training is taking part within the project entitled Best Management Practices of the U.S. Forest Services with regard to water quality, Ukraine. It's been financed by the U.S. Forest Service, which is located within the U.S. Department of Agriculture. The organizers of the training program include Forza NGO and the U.S. Forest Service. On this slide, you can see the training topics. It's an old slide. It's a little bit obsolete. So today is May the 16th. And you can see the topic of the webinar. This webinar will be delivered by Erika Borom, and the topic is low volume roads. We will be talking about design and construction. We have 4 webinars under our belts. It comes as a surprise to me that we've been working together for 1 month. The next webinar, as I have already referenced, unfortunately will not take place, or rather it will be postponed, so it will be incorporated into the next training. I'm very sorry for being a little bit hectic. So you will be able to be exposed to John's presentation, but a little bit later. Here you can see the ground rules of our webinars. They're quite flexible, but still important. So the first part of the webinar is the presentation on the topic, and you are kindly encouraged to ask any questions or articulate any comments in the course of the presentation. Then we will have a lengthy Q&A block. But once again, if you come up with questions in the course of the presentation, and then there are some follow-up questions, we will do it in the midst of the presentation as well. And then at the very end of the webinar, if time permits, we will walk you through the quiz. We designed this quiz as part of this training course because we believe that it's a great self-assessment tool for all the participants. Some other ground rules: we're going to have simultaneous interpretation, and we have our interpreter working with us, Ola. Please pick the relevant channel depending on the language that you want to hear. To this end, find a globe symbol at the bottom of the Zoom screen. It should be written interpretation there. Click on it and pick the relevant channel. So if you want to listen to everything in Ukrainian, pick the Ukrainian channel. If you want to listen to everything in English, pick the English channel, or you can have the interpretation off if you want to listen to everything in the original language. If possible, and if connectivity allows, please have your camera on, because that will definitely facilitate our communication during the webinar. And I also have a big request to all of you to have your cameras on at least for a couple of minutes for this intro, because we would like to make a screenshot. This is our final webinar within this series, so we want to capture everything for the future. If you want to say something, you unmute yourself. Whenever you're not speaking, please have your mics off because we don't want to have any background noise. If you want to ask a question, you can raise your hand virtually. There are multiple reactions on Zoom, so you can utilize them. You can raise your hand, you can clap your hands, you can have some fireworks or do whatever with these reactions. And settle down snugly. You can fetch your favorite drink. We want to make sure that you are cozy and comfortable because we have 2 hours of work ahead of us. So we want to make sure that you feel comfortable. Before we make a group photo, I would like to show this slide. Here you can see some details about our today's expert, Ms. Erika Borum. I was lucky to meet her face to face back in 2015 when I was doing an international training on watersheds. Erika made a presentation there on the construction of forest roads, and I was fascinated because she's a young, active woman. And it's a very unusual occupation for a woman, project engineer, constructor, designer. And I felt enormous experience during her presentation. So when we embarked on cooperation with the US Forest Service, and we organized another training program on forest road design and construction in the western part of Ukraine, we were very happy to invite Erika. Or to be more specific, we contacted the US Forest Service and we told them, you know what, you have this great expert. If possible, we would like to have her here and we would like her to deliver training for our colleagues. Together with another trainer, the key trainer. And for 1 week, they delivered this training in Ukraine, and it was highly appreciated by both the Ukrainian and international participants. I think we had both men and women there. I would like to note that there's another fascinating thing about Erika. She is a fervent volunteer, and she espouses the values of sustainability, sustainable development. And during the training that I participated in, not only did Erika share her expertise in the area of forest road construction and design, but she also told us a lot about waste segregation. She reminded us of the right containers in bags for different types of waste. I have it etched in my memory. And I'm very happy that we have this great opportunity to be exposed to Erika's knowledge and experience. I'm 100% positive that this presentation will be insightful and instructive for all of you. I also want to encourage all of you to start giving thought to future prospects of our cooperation. Do not hesitate to contact Erika and put forward some proposals for cooperation. Volodymyr, for example, contacted Erika because he wanted some information on the US legislation. And he received an immediate response to his request. So do not be shy, do not hesitate. Our colleagues and experts from the US Forest Service, the ones that we have within this cooperation program, are very responsive, and we are very grateful to them for their unwavering support, their time. So do not miss out on this great opportunity, because it is indeed a unique opportunity for you, for your professional development, and you can also have some of your professional interests come to fruition. At this point, I'm ready to give the floor to Erika, but once again, have your cameras on just for several seconds. We will have this screenshot, this group photo, and then you can have them off. Everyone, if possible, please have your cameras on. Okay, I will have the presentation off the screen. to fit everyone. Who's responsible for making that photo, by the way? Give us a signal when you're done. Yeah, just tell us when we can finally relax and take the smile off our face. But please have a smile plastered on your face right now. It's a request from the photographer. Alrighty, done. So thank you very much for having your cameras on. If your connectivity is good, then we will be grateful if you have your cameras on throughout the webinar. If for whatever reason you cannot have your camera on, then we will understand. And at this point, I want to pass it over to Erica.
Hello, everyone. Do you see this?
Not yet.
Okay.
I can see your presentation.
Okay. I will guess. Can you see it?
Можливо, спитати, чи всім чутно український переклад?
Так.
Okay, they want to make sure that everyone can hear the Ukrainian interpretation, and apparently, yes, everything is working.
All right. Well, hello, my Ukrainian friends. I see several familiar faces, which is amazing. It's been 8 years since I was last in Western Ukraine. So thank you for joining the Low Volume Roads presentation. Thank you to Forza for having this webinar. It's so great to see you again. So this is a 2-hour course webinar, and the Low Volume Roads training is actually a week long. I am not going to try to cover a week's worth of material in this 2 hours, but I will cover key ideas of low volume roads, and I look forward to having a discussion with all of you. So I will begin with a definition so that we all have the same understanding. The United States Department of Transportation, they define a low volume road as any road outside of a city, town, or community that has an annual average daily traffic count of 400 vehicles per day or less. Or to simplify that, we think of them as rural roads, or what I will be speaking to are forest roads. So from my perspective as a road manager for the Forest Service, our road system is several things to me. It's our most expensive and valuable investment on our forest lands. If you have been involved with road construction, you know that they are expensive to build. They are also our most potentially damaging feature on the landscape. So ensuring that best management practices are followed are critical to the longevity of our road and maintenance. So that leads us into roads being our most important and difficult stewardship responsibility. So for any new road construction or road reconstruction, it's important to answer the question, first and foremost, is the road needed? So we'll get to our first key idea. We know that roads are chronically disturbed areas. They're compacted earth, void of vegetation. And something I remember hearing a long time ago is roads, they last a very long time on our landscape. We can see wagon trails from hundreds of years ago. They are called scars on the landscape. So one thing to think about is if a road is needed, then it should come with a maintenance plan. So in other words, if you cannot afford to maintain the road, maybe consider whether or not to build it. So looking at these chronically disturbed areas, we know it's more than just the surface of a road that we need to consider. In these examples, this is how much area is disturbed from cut and fill when a road is located in rugged terrain. So in steep terrain, a road typically means a bigger scar on the landscape. Another example of chronically disturbed area includes the surface runoff from roads when it rains. So when you look at the adjacent area of this road, surface runoff is virtually non-existent on the intact vegetated forest soils. It infiltrates. But on compacted roads, it's very obvious. And as a forest roads manager, once we concentrate that flowing water, we own it, meaning it's our responsibility to deal with the flowing water and the sediment that it carries. So roads can be very erosive. The preferred methodology for roads is move vegetated soil as nature's treatment system. So looking at this diagram, left is a compacted road where we get into the soil, that causes the water to pond. The idea is to move that water off of the road to a vegetated area where it can infiltrate. So managing water runoff, ideally by infiltration, becomes our task. So we'll look at a few bad examples of roads. And looking at this picture, we see that the road surface is not the only disturbed area. We have a recently graded or disturbed ditch line that includes or adds to the bare soil. So this ditch moving directly toward Alkali Creek, connecting our road straight into the stream channel without any infiltration, resulting in a loss of water quality for this system. Now, if many of you joined the first webinar by Pauline Adams last month, she spoke about outsloped, crowned, or insloped roads. This is an example of a road that was originally designed to be outsloped. And then the road surface was never maintained, so a ditch began to form. We'll continue with more bad examples. Here is a ditch that was recently graded. So there's no vegetation growing in the ditch to allow for infiltration. But also what happened is the grader came along and took the toe of the slope out from the cut bank. So this undercut slope will continuously recruit material into the ditch and cause an erosion problem. And thinking about our roads and the disturbed area, some areas are really disturbed. And we have this cut bank where no vegetation has grown and it has resulted in a landslide. So these unstable slopes are a great source of erosion. So thinking about the angle of repose or how steep the soils can remain stable on a cut bank is important. And maintenance is always great on our roads. In this case, the road is being graded. That is good. However, the bare soils that are created by loosening with the grader, that makes this area prone to erosion. So disturbing the road surface is necessary during maintenance. And it also makes the road more prone to erosion. So one way to mitigate this is to add water and compact behind the grader as it maintains the road. Here's another bad example, and maybe Natalia will remember this picture from Arizona. This is an entrenched road, meaning that the shoulders, the road shoulders, are higher than the road surface. This is not an ideal situation. When it rains and the road gets filled with water, there is no way to move this water off the road, so it becomes a river. We want to move our water off our road surfaces and disperse it. It won't happen in this instance. And another bad example of too much water undercutting the adjacent cut slope. So one thing to think about if you are responsible for road maintenance is if a ditch is vegetated and it is functioning, there is no need to disturb it. And because road surfaces concentrate water, our goal is to disconnect our roads from our streams, including our skid trails from our streams. And here's a picture where they're directly connected. So just as our streams do not benefit from road-related sediment, sedimentation from our roads is one of our greatest water quality issues for nearby streams. We also know that our roads do not benefit from water. But why does this matter? This matters because we don't live in a bubble and we are dependent on biodiversity and the animals in our ecosystem. And most animals depend on water or streams or rivers for survival. So for example, I live in the state of Colorado in the USA, and the area of land that makes up wetlands, streams, or rivers is just 3% of the total land area in Colorado. However, it is estimated that 90 to 95% of the animals in the state rely on these rivers and wetlands for survival. And so these sensitive areas or wet areas can be very damaged by our roads. So one could argue that all of our waters are sensitive waters for those who depend on them. So if a road is really needed, going back to our first point, our goal is to coexist, so live together. So getting next to our next key idea, we've known that for a long time, our roads and our water and our roads are not friends. Climate change is making this fact more and more evident, and climate change is also showing us that Mother Nature is the true boss. So John James Audubon of the Audubon Society, he has a saying that when the bird and the book disagree, always believe the bird. To demonstrate that roads and water are not friends, here is an example of where a steep road plus a lot of rain resulting in a road failure. And this is on a steep switchback, which has become impassable. And rivers and streams, they are dynamic systems. This is the location of a former bridge site in Western Ukraine. I don't know the particular story of this bridge location, but if I had to guess, I would bet that the stream or this river is responsible for this bridge no longer being there. So roads and water are not friends. And here's a graph to highlight. When it comes to road failure and erosion, the Forest Service has found that we can prioritize our efforts by prioritizing where most of our road failures occur. And the likelihood of a road failure increases with a proximity to a stream or a river. So in this graph, it's showing that if you are within 100 meters of a stream or a river, this is where your roads are most prone to failure. So again, Mother Nature will always win. We historically built roads where roads were easy to build. So up a valley bottom, for example, because the valley bottom is gradual. But we're finding that this method is very expensive in the long term. So the engineering version of John James Audubon's quote, I have adapted to something like, when the engineer and the river disagree, always believe the engineer. So let the river decide the engineering and the road location. In other words, stay out of the way. So we'll get into some more failure examples. This is the inevitable consequence when a big storm or a big storm with a high debris load arrives at a crossing that is too small. In this instance, the road is washed away. And at this particular site, there were actually vehicles that were on the far side of the failure that were trapped there for several days. So where a road and a stream cross, which becomes inevitable, we want to minimize the stream diversion potential. Stream diversion is especially damaging. So this diversion potential is the probability of a stream moving out of the channel and down the road in the event of a culvert plugging or high flood. So our goal is zero diversion potential. In this instance, the stream diverted at a plugged culvert and is running down the road. And this is on a forest where I spent 12 years working. Luckily, this is a very low gradient valley bottom. So this water has low energy. And it's also on a lot of rock. The road is very rocky. So the damage was minimal. This is the best case scenario of a diversion. And I feel lucky to live in the Rocky Mountains where there's a lot of rock. Conversely, this is what can happen when a stream diverts down a road due to a plugged culvert. So in this instance, the water plugged at, or a culvert plugged at a crossing, and the water diverted down an inboard ditch on a steep road grade. So all of this erosion area was once the road surface. And you can see at the bottom of this photo is a drainage culvert that is likely no longer functioning. This is the same situation as previously, where a stream has diverted and cut down to a utility. So a good reminder that roads and water are not friends. Eventually, water will find its way off of the road after it's done some damage. And this is where really huge erosion can occur. So where the flowing water finds an exit point, it creates a new channel down a hill slope, sometimes resulting in a landslide, but always resulting in a lot of erosion. So all of our road stream crossings can fail. Some are more likely than others. One way to minimize that risk is to design with failure in mind. So we looked at a lot of bad examples, and it is inevitable that roads and streams will eventually cross. So we want to stay out of the way of our streams, but we'll get into looking at what that looks like at a road stream crossing. So what do we do? Getting us to our third key idea, roads and streams will eventually cross. So what do we do? Well, the Forest Service has its own methodology that it created to address this crossing. And I'll go into more detail on that. But at the very, very least, accommodate the stream width through the crossing. The idea is to maintain the stream energy. So we know we've seen examples of streams and rivers moving more than water. So we want to design for passage, where a road and a stream cross, design for passage, but passage of what? We want to design for passage of water at a flood stage, debris, the animals in that system, both the aquatic organisms and the land animals or terrestrial animals, and then sediment is always moving through these systems. So we want to allow for passage of the sediment. So the whole premise behind this is to maintain the stream's energy, maintain the system's energy. So the Forest Service's methodology for road stream crossings is called stream simulation design. This allows for aquatic organism passage while increasing flood resiliency. And so what we've moved to John James Audubon, let the stream or the system, the river, tell us what it needs. So we have started to listen to what the stream is telling us. We copy not only the gradient of the system, but we copy the width, we copy the stream bed material, the banks that would go inside of it as far as the rock size, the cross-sectional area, so maintaining the energy through the system. And comparing these two pictures, the one on top was an old culvert that was hydraulically designed. So it was designed to pass some amount of flow most years. And then it was replaced by this bottom structure, which spans the width of the stream and allows the natural processes through the crossing. So the stream simulation design, the Forest Service methodology, it maintains habitat connectivity. If you compare the picture on the top with the picture on the bottom, this is at the same site. the picture on the top is before these two culverts were replaced. And you can see how disconnected. There is probably a meter drop from the end of that culvert down to the stream. So any animals in the system have become disconnected. What we are finding is these structures are flood resilient. We have several instances where very large storms have come through at crossings where we have replaced structures with this stream simulation design. And they have been 500-year storms, 1,000-year storms, and they are not failing. They stay intact, they function, and also they are long lasting. We are seeing these structures with a design life of 75 years or more. So they have a very long lifespan. And when you compare these two pictures, you can notice that the bottom picture has a natural stream bed. So that allows for sediment to move through the system without causing the structure to erode at the bottom, or the abrasion from the sediment moving through the system. As up on the upper picture, you can see that culvert has even started to unravel from all the sediment moving through. So this is just a simple cartoon illustrating of designing for failure at a road stream crossing to prevent the diversion potential and to minimize risk. So we talked about how all road stream crossings can fail. So minimizing the risk is another important aspect. So during some flooding in 1995 and 1996, the Forest Service, they identified 258 culvert failures that failed due to debris and sediment essentially blocking the culvert. So of those 258 culverts that failed, 91% of those failures were from plugging. So this is just a depiction of how a stream will tell you if a culvert is undersized, particularly relative to width. And we can notice that in this example, the system is shaped like an hourglass. Starting with the inlet, we have this inlet transition zone where water comes down, and when the culvert is undersized, the road is essentially acting as a dam where the water slows down, and then you get a deposition zone at the inlet. And then you have water ponding behind the road, and that causes a bunch of pressure, forcing the water through a little pipe out through the outlet into this outlet transition zone. So the culvert starts to act like a fire hose, where you get the outlet, you get a lot of scour at the outlet, and that starts to disconnect the upstream from the downstream. So looking at the anatomy of an underculvert, this is very typical, where you get over widening at the inlet due to water slowing and eddies forming, and then over widening at the outlet due to scour. And this is just a photo of a culvert that failed on the forest where I worked for a long time. And they fail with small wood interlocking with sediment. And most of the time, this wood that causes these failures is no bigger than the size of your arm. They are these smaller pieces. So here is a real life photo, not a cartoon drawing, of what a failure might look like at a road stream crossing. So this may be hard to believe, but this is the preferred failure scenario where the diversion potential was avoided. So only this crossing needed to be replaced. But I would, highlight this photo, going back to our third key idea, look at the size of this culvert compared to how wide of an area this eroded out. So I would say the main cause of this failure is because that culvert was so very undersized. So maintaining or accommodating the stream width is, at very least, the importance of these road stream crossings. So the next key idea. So we started with the question, is the road needed? And then the next question, is there money and a plan to maintain the road if you build it? So if the answer to both of these questions is yes, then using best management practices for new construction is ideal. So we want to integrate resiliency and engineering informed by Mother Nature. We talked about Mother Nature as boss. This will make a road less prone to failure, and it ends up being cheaper and easier to maintain. So I believe if you joined Pauline Adams' presentation, she discussed best management practices for sensitive resources. So low volume roads has their own chapter within this best management practice guide, this technical guide, and it's the road management activities chapter that's of interest. And to highlight some of those, for new road construction, best management practices, the first thing we want to think about is locating a road to fit the terrain, following these natural contours, and limit the need for excavation or the disturbed area, the cut and fill. So we want to avoid extended steep grades, sharp curves, and switchbacks, ideally. That can be a little difficult in forest terrain where the forested area tends to be steep. So we also want to locate our roads on stable geology with well-grained soils and rock formations. So avoiding, as we already mentioned, the wetlands, the inner gorges, the overly steep slopes, unstable landforms to the extent possible. So although building a road up a valley bottom that has a river in it is the easiest location, it's going to be worth the effort and the money to build a road up out of the valley, up higher, where it will not be impacted by flood events. And on that topic, move our roads or locate our new roads as far away from water as possible. Water and roads are not friends. And we also want to minimize our number of crossings and disconnect our roads from our waters. So avoiding sensitive areas, riparian areas, wetlands, meadows, bogs, fen to the extent possible, and provide suitable distance between the roads and the water to maintain our desired conditions, our goals, and our objectives for our structures to function and for the stream's natural processes. And I just wanted to point out this picture. We have Natalia in this photo, and the red circle is showing a former bridge abutment. And you can see that that abutment is very close to the water. I suspected that this system, the stream, caused damage to the original bridge, and thus a new bridge was put on top, which is a much better location. So now that I've touched on key ideas of low volume roads, I was primarily addressing the risk and failures. I want to point out several references that may be helpful to you in the future. And these two documents are on FORS's website. And I believe you will get a copy of the presentations, and each of these are hot linked. So you can actually just click on the picture of the document and it will take you to that document. So the basics of transportation and construction of roads and best practices in the construction.
Наталка, зам'ють себе, будь ласка.
Several other references that we have that have not yet been translated or may be translated, but I don't know that they have been, are the water and road interaction teaching assistant, and then the field guide below that. These are all also hot linked, so they will take you to the website of the English version. The low volume roads engineering best management field guide, authored by Gordon Keller, who I accompanied to Ukraine 8 years ago. This middle one, this is a great resource. This will go into so much detail about road location, gradient of road, drainage dips, all of everything you need to know of building a low volume road. The stream simulation and ecological approach for providing passage for aquatic organisms at road stream crossings. This is that Forest Service methodology that I spoke about. And this is a really helpful guide for road stream crossings, starting with, maintaining the stream width. And then it's essentially copying Mother Nature, what she wants the system to look like. And then the national best management practices for water quality management on national forest system lands. So all these documents are very, very helpful. Being that we have limited time together today, I wanted to highlight some failures. But what we also have, the Forest Service has manuals and handbooks on transportation policy, and they're very comprehensive. They cover planning, pre-construction, structures, construction, maintenance, and operation. And again, these are all hot links to these handbooks. So for more information on those, you have access to that. And that goes into Forest Service policy of how we manage our road system. And with that, I want to break out into a discussion. Any questions that we may have? I want to know about your roads in Ukraine. How is it going? All sorts of things I want to learn from you. So thank you so much for your time and attention for joining us today.
Thank you, Erica. Thank you very much for this insightful and stimulating presentation. At the very beginning, I wanted to point out that it's 7 o'clock in the morning for Erica, but I forgot to mention it. And basically, she started her presentation at 6 o'clock in the morning. So we are profusely grateful to you, Erica, for your willingness to be up that early and spend this time together with us. We already have some questions in the chat. The first one is from Boris Boychuk. One of the questions is for the Ukrainian colleagues. So think who can answer it, but there are also some questions for Erica. There are two questions. What is the cost of culverts in the US, like the last examples that you demonstrated within your presentation? I guess these good examples.
Yes.
But I think it's these ones, I guess.
Yes.
Boris, are you interested in these ones? Like the good ones? So Boris, correct me if I misunderstood your question. So what is the cost of these structures? And there's another question, it's more about regulations, but let's start with the first one.
Okay. Yes, thank you for that question. This is always the question. How much do these cost? They are more expensive than the hydraulic design culverts in the short term, but we are learning that in the long term, that because they're not prone to failure, they become much cheaper. So this structure, for example, on the bottom, if I remember correctly, we replaced this in 2014. So the numbers are 2014 dollar amounts. And I believe this structure was 150,000 US dollars. And one thing I wanted to point out is this structure is actually sitting on top of concrete footings. So there are footings that are buried beneath the stream. And then this aluminum structural plate is the lid with the road going over it. It depends on the size of the system. Of course, the bigger the stream, the more expensive. So it's essentially acting as a bridge, but it's a different methodology than a bridge. Thank you for that question.
Дякую, Еріко, за відповідь.
Thank you, Erica, for the answer. There's another question from Boris. Do you have a regulation on the max road grade or gradient in the US? Or based on your experience, what is the max permissible forest road grade or gradient?
Yes, we try to keep our road grades less than 12%. Occasionally there might be, a 15%, but very minimizing those steep sections. And then on roads that are very steep, we tend to put in a lot of best management practices. So reverse grades to get the water off the road frequently. So it makes the road difficult to drive because you'll be driving and then you'll have a big bump to go over as you continue to climb up, and then another drainage dip or water bar, depending on the road. We really try to minimize the slope of the road because the steeper the road, the more maintenance the road needs.
Дякую, Еріко, за відповідь. Я повернусь
Thank you, Erica. But I want to revert to the question for the Ukrainian colleagues. Maybe someone has an answer. So the question from Boris was whether someone in Ukraine is manufacturing such structures across streams. So maybe no one is ready to answer this question right now. Volodymyr, I can see a big surprise on your face. It looks like you haven't really spotted the question. We cannot hear you. Please unmute yourself.
Ну, я, чесно кажучи, не зрозумів запитання.
To be honest, I don't really understand the question. Are you asking about these culverts that Erica demonstrated, or what kind of reinforced concrete structures you're asking about? Boris, that was a question from you, so maybe you can specify your question. So what exactly did you ask about? These arc-type structures. As Erica mentioned, it's an aluminum structure. It's a metal structure, basically. So it's not reinforced concrete. But there's a concrete footing there, as Erica referenced. But Volodymyr, the question is very simple. Do we have any manufacturers of such structures in Ukraine? Can we order these structures somewhere? So do we have contractors? Do we have manufacturers? There is one company, they tried to do it in one forestry enterprise, but they basically took a pipe, and this pipe was cut into two pieces. It was a metal pipe. It was not threaded, but it was like this old pipe. So they cut it into two pieces. The footing was not made of concrete. It was made of gabions. So there were gabions on the sides, and they mounted that pipe, but basically it was like a two-piece pipe. The shortcoming is that when we have high water, it gets plugged easily. Well, I didn't really want to pasture Erica, but I think there are some nuances there in terms of the passage of ice or debris and things like that, whether structures like that are resilient in the long term. But unfortunately, we don't really have any manufacturers of such culverts in Ukraine. Volodymyr, thank you very much. So that was your question, right, to Erica. So maybe Erica, you can answer that question in terms of the passage and plugging and things like that.
Yes, so how we design these structures, we design for the 100-year recurrence interval or the 100-year storm. And so we size these, we use the width, and then typically add bank lines in there. And then we make sure that we allow for 20% freeboard or 20% air through the structure at that design flow, so that floating debris and anything that's moving through the system moves through our crossing. And what we've found is that we design these for a 100-year storm, but they have survived.
Can you explain what you mean by this 100 storm? What is that? Because I don't really understand.
Yes, so it's a hydrology term. It's the probability that a storm of a certain magnitude, so a 100-year storm has a 1% probability that a magnitude of so much water will arrive at that location in any given year. And so it's a hydrology term that we use to classify our storm sizes in the US. So we say a 100-year storm has a 1% probability of happening in any given year. And it has really, it puts a flow to sizing these structures. So for example, I don't have the metric conversion. I was going to give the size of this particular site right here that we're looking at. We size it for a specific flow. So however, like cubic meters per second arriving to that site at that time. And then we make sure that we have space for floating debris to move through. So what we found was we designed these for a 100-year storm, but they are surviving 500-year storms, 1,000-year storms. So very, very, very big flood events. So they have become very flood resilient.
Ого. Дякую, Еріко. Володимир Леонідович.
Thank you, Erica. Volodymyr, you have a raised hand. I think you were the first one because we can see two raised hands, but Volodymyr, you were the first one. I have a question for Erica. I mean, we're talking about low volume roads. So you use only 1% probability for such structures? So you do not really believe that this 1% probability is fit for such roads? Well, I know more about forest roads. You have 3% probability, or like wooden bridges. The max flood that occurs once per 33 years. But I mean, if we're talking about low volume roads, only 1% probability. It's not that I do not believe, I just want to make sure that I got it right.
So the bridges in Ukraine are designed for a flood that might occur every 33 years. Is that correct? Did I understand, Vladimir?
If we're talking about wooden bridges, yes.
Okay. So yes, these are designed.
But my question was about forest roads.
Yes.
Forest roads.
Yes. So our stand.
Public roads are 1% probability, like 500-year storm. I've never heard of something like that.
Yes. So as we're with climate change, we're seeing bigger and bigger flood events. Yes, for forest roads, that's all I've ever worked on. That's how we size our structure for a flood event that might occur every 100 years. And that way, we can feel good about setting these structures and then walking away and knowing that we will not have to go back to maintain or unplug the structure, or it minimizes maintenance. It's more expensive up front, but in the long term, it becomes cheaper because they are not prone to failure. So yes, a storm that we expect to happen every 100 years.
Is it necessary for all type of forest road?
It's in our, yes, that's our policy. So sometimes there are exceptions, but this is for most of our roads where we try to go.
Дякую, Еріка. Дякую.
Thank you very much for that. Thank you, Erica. Thank you, Volodymyr. We have one more raised hand. So Oleg Steranivsky has a question. Oleg, do you want to articulate the question that you wrote down in the chat, or is it a new question? I would like to veer back to Boris's question. The question about whether such reinforced concrete structures are manufactured in Ukraine. Well, first of all, these are not reinforced concrete structures. I would like to note that I don't know any manufacturers of such structures in Ukraine, but I think that it should not be problematic to produce such structures. But at the same time, we received a tentative cost of such structures from Erica. I mean, the upfront cost is quite high, so 150,000 USD. Based on our design experience, we try to minimize the cost of forest roads and also road stream crossings. So we try to design standardized approach like round pipes, culverts. We even prefer culverts, pipes, not bridges, because bridges are more expensive as a rule. I mean, we can also design for such road stream crossings, but it's all about the cost in the end. But to the best of my understanding, in the long term, the cost might be lower. I mean, if we take into account the maintenance of this bridge or any other type of crossing. So this is just an addition to Boris's question. Oleg, thank you very much. Yuri, you raised your hand, but could you wait a little bit because we have several questions that have been lingering in the chat for quite a while. So let's start with the chat, but then keep your hand raised. So there was a question from Oleg. Do you develop design documentation on forest road construction in the US? And if yes, what is part of this design documentation? Maybe like you have some standard design documentation.
Yes. So our process, we always start with environmental analysis. Being that I work for a federal land management agency, we are required by law to comply with the National Environmental Policy Act. So this requires federal agencies to assess the environmental effects of any proposed action prior to making a decision. And so there are different levels of analysis, but this would occur for a new road or road reconstruction or a road realignment. So that's the start of our documentation. And then what we would do is we would go into the pre-construction handbook, or the planning handbook, and then the pre-construction handbook. So we would essentially follow our policy through our handbooks for that documentation process for a new road or for a road realignment or reconstruction. So that's the documentation process is lined out in our policy. And for bridges, we require the regional structural engineer to review the design to ensure all of the engineering calculations are adequate, that they meet the load requirement, because yes, these are low volume forest roads. However, they have to be able to handle very large equipment like log trucks, all of the timber harvesting equipment that uses these roads. So they tend to be, there are expenses and some engineering that must go up front for all of our roads that need to be newly constructed or reconstructed.
Дякую, Еріка, за відповідь.
Thank you, Erika, for the answer. I have another brief question. So the design documentation that you draft in the US, does it include the cost estimate of the future road?
It will likely include a rough cost estimate. The actual cost estimate is typically completed when the road is about to be built. And at that point, a thorough cost estimate, if the road is to be contracted, then that's the process. After the design is complete, then we will do a thorough cost estimate. But in the planning, it will be a rough estimate based on the type of terrain and an estimate of dollar per mile or dollar per kilometer of road that is to be built. So as we get closer to construction, the cost estimate becomes more refined.
Thank you very much. Another brief one. What is the average cost of 1 kilometer of forest road construction?
This is a good question. I actually do not have the answer, and it depends on the terrain. Very steep terrain will cost more. So the Forest Service in the last 20 years has been directed to reduce the number of kilometers of roads. So we are not actually building very many new roads. And I've not been involved with any new road construction recently. So I'm sorry, I don't have an answer for that. That's a good question. I'd have to look into it and get back to you.
Можливо, ми попросимо Еріку пошукати.
Erica, maybe we will ask you to inquire about this from your colleagues and then just send the answer to me, and then I will forward it to everyone, or at least to Oleg. I hope that it's fine with you, Erica. We have several more questions.
Валерія Кривов'язого.
There was a question from Valery. Which material is this structure made of? But Erica, you detailed that. So what is this crossing made of? Maybe you can repeat it once again for everyone. The one that we can see on the slide.
Okay, so this one it's got a spread footing, so concrete footing. And then this structure is aluminum. You can see some bolts right here. So it's plates of aluminum bolted together that then have ribs to reinforce it for structural. And then the fill around it adds to the structural component of this aluminum structure. They also, this particular one is is aluminum, but they also make steel. Similar idea where they are bolted together. Or if we have a really big site, we will probably use a bridge.
Дякую, Еріко. Наступне запитання у нас від пані Оксани Фенцик. Чи контролює...
Thank you, Erica. There's another question from Oksana. Does the U.S. Service control the construction of forest roads by private users? If yes, then how?
Yeah, if this is an interesting topic about road ownership. If the road is owned by the Forest Service, the road must follow Forest Service policy, including the environmental analysis. Sometimes we have roads in the forest that are on we have a private parcel, a privately owned parcel within the forest. And if the road is on that private parcel, we have no jurisdiction. But if a road is going to that private parcel, yes, we are required to follow Forest Service policy for design, maintenance, construction of that road.
Дякую за запитання. За відповідь.
Thank you for the answer, Erica. There was also a follow-up question from Boris. 20% of the normal stream size, but Natalia does not really understand what this question is about. Boris, can you remind me what the question is about? Boris, if you can unmute yourself, could you maybe specify this question, because it's a little bit fragmented, so I don't really understand what exactly you're asking about. "20% of the normal stream size," I think it has to do with the 20% that you mentioned, something about 20% above the stream, or something like that. So he's asking whether it's 20% of the normal stream size or 20% of the max spring flood scale or something like that.
So 20%, what are the 20% I referred to would be the amount of air in the freeboard. So the space between a high flood and the top of the structure is the 20% I was referring to. So we size our structure to meet the width of the stream, and then that 20% is a double check to make sure we have enough room, 20%, to pass floating debris at our design flood.
І це до нормального розміру.
But it's basically 20% of the flood magnitude. So it's 20% of the normal stream size or 20% of the flooded stream size?
Of the 20% of the flood. So if the flood in this, I think you can see my cursor. So if the flood came up to here, if the floodwaters were this high, we would need to have this 20% or more space to allow for other debris and material to go through. So that's 20% at flood stage.
Дякую, дякую, Ерік.
Thank you, Erica. But it's of the annual flood level or the 1% probability flood level? 1%?
The 1% probability flood level.
1% паводку. Пане Юрію, дякую, що ви дочекалися.
Yuri, thank you very much for your patience. Yuri Khomyak, you vanished off my screen. A very interesting presentation. Thank you very much for it. And I have a practical question. Forest roads in the US are designed, constructed, and used for heavy vehicles, because you don't really have 4 or 5 cubic meters. You have like 40, 50, whatever. So basically you construct mostly paved roads. Hence my question. Where do you take this paving from? And are you allowed to excavate rocks or stones from streams? So can you expound on that?
Yes. Most of our forest roads are not paved. They are either native surfaced, or if they are very heavily used, they might have an aggregate surface, a road base on top. So there are very, very few paved roads in the forest, not many. We do develop quarries for material for building roads, but we never take rock or material from our streams or our rivers. We want those to remain intact because they are considered sensitive areas. In the Forest Service, we are multiple use, and so we have to consider the animals on the forest. We have to consider the timber sales that are taking timber off the forest. We have to consider other mineral extraction like mining. We also have a lot of recreation use where people will use the forest to camp or go hiking or recreate. So we have many, many uses, and the environmental policy that we must follow very much discourages removing material from our stream systems or sensitive areas.
Thank you very much. And another question. On the slide that we can see right now, on top of this road, there's something there. I think it's the picture below. What is that?
This here was put into the contract. It's a erosion control fabric that is made out of decomposing or biodegradable material to allow for this slope to revegetate. So it's part of a best management practice to keep the soil in place and allow for vegetation to grow right after construction.
Дякую, пані Еріка. Дякую.
Thank you very much, Erica. Well, thank you for the questions and the answers. We have another question in the chat from Valerie, and it's directly linked to Yuri's questions. What kind of road surfaces are used in the US? Well, partially we received the answer. And do you use metallurgy waste, or do you use like any concrete mixes?
Concrete, yes. We do not, I don't believe we have any concrete surfaced roads. So I'll briefly talk about, we have 5 maintenance levels of road on the forest, in the Forest Service. And level 5 would be that small percentage of paved roads. And these are typically in very high use areas, and they tend to be double lane and paved. So more similar to an urban road, but we have very few of those. And then that's level 5. Level 4 is we maintain to a moderate degree of user comfort. So their speeds are usually a little increased, and most have an aggregate surface and are 2 lanes. And then the next level is our level 3, which is maintained to be passable by a passenger car and by a prudent driver. So there may be some bumps or some rocks in the road, but for the most part, a passenger vehicle can navigate a level 3 road. And then level 2, this tends to be a high clearance, for high clearance vehicles. User convenience is not a consideration, and these are more rugged, rough roads. And then our level 1 roads are typically roads that are in storage. Maybe they access to timber sale, but they typically are gated, and they are administrative use only. So only the Forest Service can access those roads, and they might just be closed for a while until the trees grow big enough to go harvest again. So that's level 1.
Дякую. Дякую за відповідь.
Thank you very much. There's another question from Boris. What are the methods that you use for the artificial vegetation of steep slopes along forest roads to prevent soil erosion, and which methods have demonstrated themselves best?
So the one method that we have started to use is to remove the topsoil and stockpile this topsoil in a specific area. Oftentimes that topsoil has a seed bank in it. And so when, after construction, you take that topsoil stockpile and you scatter it back on to the area that's been disturbed. And then we typically will reseed that topsoil with a seed mix of species that are native to the area. And so you have two benefits from that. You have the topsoil and the nutrients from that topsoil to feed the new plants, to get them to establish and stabilize the constructed area. And then you also have the seed bank that was in that topsoil that has the native seed in it that acts as an added benefit. So we very occasionally will add this erosion control blanket to help stabilize a slope. But we have started to move away from this because what we are finding is this blanket is thick enough. It keeps the soil in place, but it makes it harder for plants to grow through. So a lot of times, if we can avoid using these fabrics, we will. But the topsoil with that seed bank and those nutrients, harvesting that at any construction site is what we try to do.
Дякую, Еріка.
Thank you, Erica. We have some more questions. There's one from Yuri Hromak. Do you have details on the density of forest roads in the US, kilometers per 1,000 hectares, or maybe any other units that you can use? Density of forest roads.
Yes.
So you can answer in any units that are more comfortable for you.
That is, I don't know off the top of my head the density of forest roads, but I do know we have in all of the US 380,000 miles of forest roads. So that is enough to wrap around the earth at the equator 15 times. So we have so many miles of road. The Forest Service lands, it's not a continuous area. We have some forests that are continuous, but there are 155 different national forests in the US, and each of those forests have their own area, and each of those areas have their own density of roads. So it is very hard to put a number to all of Forest Service lands. But I will say in the state of Colorado where I live, the Forest Service manages more miles of road than the State Department of Transportation. So it is a lot.
Дякую, Еріка. Ми
Thank you, Erica.
направимо це запитання, пане Юрію, до нашої колеги Челет з міжнародних.
Yuri, this is a question for Chilette from the international programs. I mean, we will forward this question to Chilette, so maybe she can inquire from the colleagues, especially the ones that are responsible for design and forecasting. But I think you got the point. I mean, different national forests vary, and there's no continuity in the lands. So the density of forest roads will vary depending on where you are and depending on the national forest and the conditions thereof. There's one more question from Yuri Derbal. Does the U.S. Forest Service purchase construction materials, rocks, pebbles from quarries for the construction of their roads? So does the U.S. Forest Service pay for construction materials? So do you have to purchase construction materials? Do you have to pay the treasury, the state treasury for it?
Yeah, so sometimes we have quarries set up where we can make aggregate. And when those are not available, we will purchase from a commercial source. So it's a mix. And in order to develop a quarry, that process has to go through environmental analysis. So it is cheaper, but it is more effort to analyze to make sure there are no sensitive species that will be impacted by a quarry. So it is a mix. Yes, we purchase from commercial sources, and sometimes we create material on the forest from a quarry.
Дякую, Еріка. А коли ви розробляєте...
Thank you, Erica. But when you develop your own quarries, do you have to pay for that, like for the use of, like even,
No.
I mean, it's your own land, but still you have to pay for it?
No, the cost comes from, typically we'll have to contract a company to supply the rock crushing, the equipment. So there is some cost that comes with either renting or contracting the use of the equipment to get the material that is needed to process the material. So we are not paying for the material itself, but we are paying for the use of equipment to create the material.
Зрозуміло. Дякую, Еріка.
Right. Thank you for that. And there's also great comment from Pauline Adams. U.S. Forest Service typically uses aluminum culverts in streams where water chemistry is acidic to prevent rust and last longer. Steel culverts are less expensive, so they're not that expensive, but steel culverts are used where water quality is neutral, pH equals 7. So this is just an additional comment on the questions about the materials used for the manufacturing of culverts. Any other questions? I don't really see anything else in the chat. If I skipped a question, your question in the chat, please let me know. Any other questions?
Будь ласка, Володимир Леонідович, бачу вашу підняту руку.
Volodymyr, go ahead. I will try to help Erica. Usually, when we construct roads, not only forest roads, there's surplus of soil. And if it's necessary to divert water, you create channels and you use some other water diversion means. In Ukraine, if there's soil, then we usually take it from the side, and then you do not pay for it. Under Ukrainian legislation, if you develop soil to a depth of up to 2 meters, you do not require any additional permits, and you don't really need to get any licenses. That was just a comment about the state of play in Ukraine. Thank you, Volodymyr. So that was related to Yuri's question, right? That was just your comment on that. My point was a little bit different. My question was more about imported materials, you know, like when you excavate material from quarries. So Volodymyr, whatever you said has nothing to do with my question, because my question was about quarries. Yuri, we're talking about forest roads. Forest roads are low volume roads and it's very expensive to utilize imported or brought in material. So our Ukrainian regulations have minimum requirements for forest roads. Well, but you are describing the situation in Ukraine, but it's a completely different approach in the US. No, Erica said that basically they take material from their own quarries. Colleagues, I believe that you can have this discussion offline. And I suggest that we revert to the essence of our presentation. Should you have any other questions about Erica's presentation, please articulate them. So I have another question. I'm a little bit surprised that you don't really have that many paved forest roads in the US. Based on that, I can draw a conclusion that there are some limitations on the use of such forest roads depending on the weather conditions or the season. Am I right? Since they are not paved.
Yes, it depends on the area. Some roads become impassable when wet. Some roads we have in very rocky areas where they function fine in wet weather. Depending on where you are in the country, in Colorado, for example, we close our roads generally from November through May because they are in the mountains and they have a lot of snow. So to avoid damaging the road surface, we have road closures, seasonal closures. Of course, the climate changes all across the US, depending on whether you are north or south or on the coast or in the mountains. So each forest has its own policy for road closures. So yes, sometimes the roads become impassable and sometimes they are in rocky areas where they have good drainage and the road surface is adequate for driving. But paving our roads, because we have so many miles, it would be too expensive. Paving is very expensive.
Зрозуміло, дякую.
Thank you very much for that. We have another question in the chat from Valerie. What is the max estimated load on a road?
So
maybe for different levels or categories of roads?
Yes, our design load is based off of, this is very United States specific and very policy specific. So we design our roads for, it's called HL93 load rating. So it's for very, very heavy loads, similar to what is required on a highway. So our load requirements are similar to a highway load requirement. No different.
Дякую. І в продовження цього питання.
And there's a follow-up question. Who is entitled to drive on forest roads? As a citizen, do I have the right to go there with my own car or bicycle?
Yes. So with the exception of a level 1 road, which is closed to the public, level 2 through 5 roads, the public is allowed and encouraged to use the roads, either with a bicycle or a vehicle. some roads we restrict. There are some recreation vehicles like four-wheelers that are restricted on forest roads in certain sections. So some of our roads are highway legal vehicles only. But all of our roads we encourage the public to use. It is public lands.
Дякую. Я від себе задам питання.
Thank you. I have a question on my own part. What about those roads that are closed? I mean, if they're closed from November through May.
Oh, yes.
So they're closed for everyone, right?
Yes, during the closure. But there is an exception. In some areas where it's very snowy, we allow for snow machines to use the area. It's very complicated. We have a whole travel management plan. Each forest has a travel management plan. And then each forest has a motor vehicle use map, which tells the public what is open for use at what times.
Дякую за відповідь. Володимир Леонідович,
Thank you for the answer. Volodymyr, I want to finish with Valeri's questions and then over to you. In Austria, for example, there is mandatory insurance for mountain bikes. Do you have a similar practice in place?
No. No, there is no separate insurance for mountain bikes.
Дякую. І Володимир Леонідович, секундочку, вже закрию.
Thank you, Volodymyr. I need to finish with Valery. Do you have an e-map of forest roads, electronic map of forest roads?
Мається на увазі в доступі для...
Is it available to the public?
Yeah, yes. So I mentioned there are 155 different national forests. Each national forest has their own website. And on each of those websites is their own forest map. So as we mentioned before, this isn't a continuous, the Forest Service is not a continuous area in the US. There are pockets. And so each of those pockets or forests have their own mapping and boundaries and their own maps and their own travel management plan. So each forest, yes, you can go on their website and get their map.
Дякую, гарно, Еріко. Якщо можна
Thank you, Erica.
Поки Володимир Леонідович буде формулювати питання, скинути нам, наприклад, сайт твого.
Erica, could you post a link to the website of your national forest?
Yes.
Or the one that you worked for in the past?
Yes.
Just for people to check it out.
Of course.
I'm sure that you can find a lot of details there, like what kind of vehicles can have access, road closure, and things like that. Boris, you need to wait a little bit because there's a question from Boris in the chat, but Volodymyr has been waiting too long. It's not a question, it's a comment. It's a comment for Erica. It's a comment on load. We have a very similar practice. So everything that can drive on public roads, I mean, there are some limitations there on length, width, and height. It's the same with forest roads. As for road closure, Erica, thank you, because 1 month ago, you sent me a link to some documentation. I perused it, and we are crafting new regulations right now. And in item 556, we included 3 items. It's allowed to restrict traffic or impose a ban on traffic. So this is something that we have already incorporated into our new regulations based on the documents from the US and basically grounded in the Austrian experience, grounded in the German experience, because they have similar restrictions. And back to Valeri's question, Valerie, I will send you my article published in 2021. And there you can find a link to a US source that stipulates that about 80% of forest roads are publicly available electronically. Valerie, I will find that article of mine and I will definitely forward it to you.
I'm happy to have helped.
Спасибі за коментар і за те, що ви
Volodymyr, thank you for your comment. And it's fantastic that you're trying to incorporate the US best practices in Ukraine. We have one more question in the chat from Boris Boychuk. Who constructs more forest roads? National forests or private contractors? Are you asking about who constructs more or on whose lands there are more forest roads? Because that's an important difference. So are you asking who constructs more forest roads? National Forests of the US Forest Service or private contractors?
That is a great question. I would say it depends on the forest. So for example, the White River National Forest has their own road crew, a construction and maintenance crew, where they have their own equipment and they do a lot of the maintenance. Sometimes we contract out new construction. As I mentioned before, we aren't constructing a lot of new roads at this time. So it very much depends on the forest. Our road crew is capable of building new roads. What they have spent a lot of time doing in the past is actually decommissioning roads, where they will go and decompact and recontour roads that are no longer needed and to restore those back to the forest. So some forests do not have a road crew or a construction crew, and so they have to contract everything out. It very much depends on how each individual forest operates.
Я відключаю. Дякую гарно за відповідь.
Struggling with the microphone. Thank you very much, Erica, for the answer. Any other questions? If there are no questions, then I want to ask a question that Volodymyr forwarded to Erica several days ago. And it's a question about environmental requirements for forest road design and construction. Environmental requirements for forest road design and construction, apart from this environmental analysis that you have already alluded to.
So as part of the environmental analysis, this is where we consider environmental and ecological requirements. So each individual forest typically has an ecologist or a botanist. There are wildlife biologists, fisheries biologists, archaeologists, many different resource inputs. We have landscape architects to look at visuals. We have, if it's a timber road, timber is involved. if it's a road, engineering is involved. And so we request input from the specialists on the forest to tell us if there is an area where a sensitive species might be located, a plant or an animal. In some cases, if it's threatened or endangered, there are very strict requirements. So yes, we definitely consider environmental and ecological in our road projects. That's something that's required by law through the National Environmental Policy Act, but also because the Forest Service is so multiple use, so many users, we will also get input from the public. And so frequently we will ask the public for the impacts of a specific project to them in their area. And with that impact, a lot of times economics comes into play. So every project, there are many, many considerations, environmental and ecological and economical.
Дякую за відповідь.
Thank you for the answer, Erica. There's another question from Boris. What is the structural setup of national forests in the US? One per state or a different approach?
Oh, yeah, so each forest tends to be, it's not one per state because there are only 50 states in the US. So for example, Alaska has 2 national forests. A lot of times they are geographically located and designated. So for example, in Colorado, the White River National Forest, where I spent a lot of time, we are surrounded by several other national forests to the southwest, to the north, to the southeast, and to the south. So there are several national forests in Colorado. A lot of the times it's geography based. Maybe perhaps like in Colorado, the Continental Divide goes through the Rocky Mountains. And so a lot of times that geography separates one forest from the next. So the geology and the geography tend to designate different forests.
Дякую за відповідь і за запитання.
Erica, thank you very much. I wanted to find a map of the national forest, but I mean, if you Google national forest map, then you can find some maps. So you will be able to see what they look like. And another question from Boris: do national forests have the status of a legal entity, or you have this single US forest that has branches in the form of national forests? So what is the status of national forests?
Yes, that is a very interesting question. So typically each forest has a forest supervisor and staff below it. So if the issue is local, it will be handled at a local level. Occasionally, issues escalate higher. And when they escalate higher, then they will be addressed by the regional office, which are each regional office has several forests under them. And then if it's a very, very big issue, it will be escalated to the national office, which is based in Washington, D.C. So depending on the issue and what the issue is and how big the issue is, most of the time it is handled locally.
Erica, but the question was about the status. Like you have like single U.S. Forest Service, and then you have branches in the form of national forests, or like each national forest is a separate legal entity?
Oh, no. So each national forest, sorry, I misunderstood the question. Each national forest is under National Forest System lands. So each forest is part of the bigger Forest Service.
Дякую, Еріка, за відповідь і дякую всім за участь.
Thank you, Erica, for the answer. Our interpreter, Ola, has to leave in a couple of minutes because this webinar was scheduled until 5 p.m. If you have more questions, you can email them to us. You have our contacts. So we will definitely forward these questions to the right US experts via international programs, via Gillette. So whenever they have some time on their hands, they will definitely answer your questions.
Дякую Еріці за презентацію.
Profusely grateful to Erica for her presentation. A big thank you to all the participants for their active participation and engagement. We're saying bye for some time, for several months, because in several months we will have another training program. I would like to briefly elucidate the next steps following this webinar. I will put together all the training materials and I will definitely forward them to all the registrants, because I have already disseminated the materials to those participants that actually participated in our webinars. But now I will put together the entire training package and I will propagate it to all of you. And then we will prepare certificates for those of you who participated in our webinar. So basically, we will have participation-based certificates. We know who participated in which webinar, and based on that, you will receive a certificate. If you want to receive a certificate, and if you want one of the webinars that you did not participate in to be included there, then just email me about it. And then I will explain individually to you how it can be done. That's why we prepared quizzes, like the self-assessment thing. So at your leisure time, you can still listen to the webinar, you can complete the quiz, and based on that, you can receive a certificate for the webinar that you didn't participate in. I can see a raised hand from Oleg. I have a question or a comment. I'm not really sure whether it's for Natalia or Erica. Thank you very much for the information that you have communicated to us today. It's very important and valuable for Ukraine because you highlighted the ecological and environmental aspects that should be taken into account during road construction. So my question is as follows. Is it okay if we use these training materials as part of our training process? Because this is something that we would like to communicate to our students, not only students, but also engineers, because from time to time we organize workshops for them as well. So do we have the green light from you?
Please. Yes.
Дякую. Дякую.
Yeah.
Дякую.
Thank you for that.
Дякую, Еріка. І так само,
Thank you, Erica.
ви не на всіх наших вебінарах були.
Oleg, you did not participate in all our webinars, but you helped us with the terminology, so thank you very much for that.
Також ми з іншими нашими експертками погодили, що їхні матеріали...
And you can also use the training materials from all our other experts, but just include the references.
Дякую.
Thank you.
Можливо, хтось хоче сказати ще кілька слів. Олю, так. Дуже дякуємо Олі за роботу. Якщо раптом...
Unfortunately, I have to leave. I'm very sorry, but unfortunately, I have to leave. So thank you very much. It's been a pleasure.
Thank you.
До зустрічі, Олі. Будь ласка.
Наталка, єдине тоді попроси Еріку перейти на ічелет на Original Language, бо ти будеш зараз, вони не будуть чути тебе на каналі.
Настрой. Если нас возьмут,
Erika and Erika Chelet and other English-speaking colleagues, please choose original audio, because Ola, our interpreter, she left. She had to run, and in case we will need to translate something, I will do that.
Okay. Done.
Thank you. Будь ласка, якщо хтось хоче щось сказати, то можете це зробити. Я вам дякую, щиро дякую за участь, за те, що ви були з нами ці 5 тижнів, 5 вебінарів. Ми були дуже раді вас бачити, спілкуватися.
Якщо можна.
Так, пані Оксана.
Да, я хотіла би дуже подякувати за ці вебінари, як для мене. Дуже корисна інформація, і вона корисна тим, що вона практично застосовується. Тобто це не просто теорія, а то, що вже застосовується, випробовано роками, і то, що ми можемо брати для себе. Дякую вам.
Дякую, пані Оксано. Дякую, гарно. Володимир Леонідович.
Ну, я з 2 питаннями. Перше, із подякою для пані Ерики. Дуже цікава інформація. Ну і попередні контакти, так само вони дуже важливі. І я би хотів ще попросити наступне. Коли там давали інформацію про неї, то написано, що вона любить волонтерити і любить науку. То я би попросив, аби ще дописали любить вчених, і чи можливо потім ще до неї звертатися з питаннями такими конкретними.
Erika, Volodymyr wants to thank you for this presentation, first of all, and he says that you in your bio there is written that you like to volunteer and like science, and he's asking whether you like scientists as well. Actually, his question is if he can send requests to you in case there are some questions or need in materials or in information, whether it's possible that he contacts you or.
Of course, yes. I'm always happy to help our Ukrainian friends.
Звісно, Еріка каже, що вона завжди рада допомогти своїм українським друзям. Ми їй за це вдячні дуже.
Дякую.
Спасибі. Дякую, гарно. Можливо, хтось хоче ще щось сказати. Я бачу, що не дуже всі хочуть розходитися, значить, класно тут. Будь ласка, я готова перекладати.
Дозвольте, Наталя.
Так, пане Юрію, будь ласка.
Хочу подякувати найперше вам і вашій організації за досить таку цікавий цикл вебінарів чи лекцій. Я для себе почерпнув дуже багато, відверто кажучи. Ось. І особливо хочу сьогодні подякувати Еріці за таку практичну лекцію, яка для мене відкрила також світ лісових доріг в Америці, скажімо так. Дякую, Еріка.
Дякую, пане Юрію. Erika, thank you very much for this presentation, which helped to open up the world of forest roads in the United States. Yuri is thankful for that. Пане Юрію, я від громадської організації Форза скажу, що ми це робимо для вас, і ми дуже раді чути такі слова. Це означає, що ця інформація і вона потрібна, і наша робота, вона не марна.
Так, дякую. Дякую.
Дякую, гарно. Спасибі. Можливо, хтось хоче ще сказати. Бажаємо гарного дня всім, вечора, вже в Україні вже вечір, у Еріки 8 ранку. Як дожити до 8 ранку? Встати в 6 і провести для українських друзів вебінар.